so let's take a look at some of the rules of Boolean algebra. So let's start with what is Boolean algebra. It's just a math technique that lets us simplify logic expressions, okay? So the simplified expressions give us a logic circuit that's equivalent to the original circuit and requires fewer gates. What's the definition of equivalent? It means it's going to give us the same truth table. And here you see a picture of a simplified Boolean circuit and the expression you started with and what you ended up with. So George Boole was the man who first came up with the rules, and he worked with mathematical logic, algebra, binary number system, okay? And so he's had a very unique and specific influence on the development of computers and computing equipment. So let's look at some of the theorems, all right? So these are one variable, single variable, and they're from the AND function, all right? So if we say x and 0, well, think about it. An AND gate for the output to be 1 means that both inputs have to be 1. So that will never be anything but 0, all right? So that helps you understand theorem 1. Theorem 2, x and 1. All right, so one input's always 1. So when x is 1, then the AND table will be 1. So really, whatever the output of that depends directly on what x is, all right? If x is 1, it'll be 1. If x is 0, it'll be 0. All right, the third one, theorem 3, x and x. So when we're looking at the x and x, all right, so basically if x is 0, both will be 0 and the output will be 0. Or if both are 1, the AND gate would be 1, and so the output would be 1. So that works out to be x and x is the same as x. All right, x and not x. If x is 1, then not x will be 0. So that coming into an AND gate will always be 0. If x is 0, then not x would be 1. A 0 and a 1 will still make a 0 in an AND function. Now let's look at the OR function, all right? So you have, and this is just one variable again, x or 0. All right, so from an OR gate, anytime one of them is 1, it will be 1. So the 0 will never be 1. So the output of that OR gate will be 1 when x is 1. Okay, it'll be 0 when x is 0. X or 1. Well, one of those inputs is always 1. That's the same as saying 1. So x or 1 becomes 1. X or x. Okay, that turns out if x is 0, you have 0 or 0. That's going to give you 0 out of an OR gate. If you have 1, you have 1 or 1. That's going to be 1 out of an OR gate. All right, and x or not x. Well, one of those is always 1. So you know that that output will always be 1 as well. All right, so and here's the last one about a single variable. Not x is x. Think about it. If you bring x through a NOT gate, you get not x. So if this is 0, this becomes 1. You take 1 through a NOT gate again. What happens? It becomes not x, but that turns it back to what it was originally. Okay, so that'll give you a look at the theorems that we're going to use. I recommend that you use a reference sheet to help you keep track of these, okay? And I'll load that online for you. So here's our first example, all right? And we're supposed to simplify this one. So why don't you look back at the theorems you've just been given and just take a minute to try to simplify this yourself, all right? And see how you do. All right, so go ahead and pause the video here. All right, so now that maybe you've worked on that for a second, let's go through it, and I'll show you what it looks like. So here's the solution. All right, we start with A and B. Well, we said A and A was the same as A. So that means this first term, A and B, becomes A and B. All right? So what did we say about then if we look at the next term, C and not C? Well, one of those is 1, the other one is 0, so that's going to be 0. All right, so we get A and B or 0 and D. Okay, 0 and anything was going to be 0. So we have A and B or 0. Okay, well, 0 is not going to give us anything out of the OR gate, right? If we combine those two, it would only be 1 when A and B are 1. So that becomes just A and B, and the final answer is this expression simplifies down to A and B. All right, let's look at one more example. Again, take your rules out, or look at the rules I went over earlier, and take a second and try to simplify this. So pause the video now. All right, now that you've worked on that for a few minutes, let's look at what this one might look like. All right, so let's look at B and B. All right, that's just going to be B, so we get B and not C. B and not C and not C. Well, not C and not C is the same as not C, so we have B and not C or B and not C. All right, not A and B and 1. All right, so not A and B and 1. Well, I'll follow it through the way I have it here. So B or not C or B or not C is the same as saying like X or X, okay? So that becomes B or not C, okay? And then we have not A and B and 1, all right? The and 1 disappears there. That's like saying A and 1, okay? So we have not A and B is what comes out of that term, all right? Right here. And then here we're going to have something and 0. Well, that's always going to be 0. So now we have this term plus that term. So this term or 0. Well, that 0 will never give a 1 coming through an OR gate. So it just reduces down to being B and not C or not A and B.